Let's start. Thanks for joining me for this last session of today. So I'm guessing that you're all a bit tired and I don't know, worried about your jobs being taken over by AI. I understood in the other talk. So I hope there's still a little bit of enthusiasm left. We're not going to deep dive. I saw in the program that they listed this session as fun and geeky. I'm going to try to live up to that. It's combining two of my own passions, which is coding and space, which is more of an enthusiasm thing. So let's get started. A little bit about me. My name is Jasper Siegmund. It's my wife and my two kids. I like being outside when it doesn't rain. And on the bottom right is our team at MStack. We're a bunch of software developers who mainly code within the Microsoft space, so C#, Azure, founded solutions. So that's my background. Started as a developer, did some architectural work, and now I have some people management tasks as well. And I have one big thing that I'm excited about always, and that's space. Probably most of you have seen James Webb somewhere in the news at some point of time. These kinds of pictures I find very intriguing. NASA said in their press publication that if you go onto a beach and you take 1 grain of sand and you hold it at arm's length to the sky, if you zoom in on that area, you get this picture. So imagine, with all the grains of sand which you can use to fill up the sky, how big our universe is. And that's mind-boggling to think about that. And then looking at these kinds of things, highly technical solutions that we can shoot into space, and they travel millions of miles and they take these awesome photographs. And then in my daily life, I come across IT teams with overrun budgets, delays. It's always something. And this is a list of projects from the Dutch government. I don't want to bash the government because I know this is not a government specific thing, but these figures are very easy to find, and from corporate companies, you don't really get this kind of information. So it's not to bash the government, but there's a lot of failure going on when we look at IT. And I started wondering, okay, as a humanity, as mankind, how can we sometimes do such awesome things and on other things completely and miserably fail? And then the easy thing is to think, it's incompetence, right? All these people working on these government projects, they're incompetent. They don't know what they're doing. They're messed up developers, or there are too many managers, too many consultants telling them what to do or what not to do. It's probably that. But to be honest, I worked in government projects myself as well. We had budget overruns as well, so I'm part of the problem, I guess. Doing more and more projects, I tend to think that this is the actual problem. That whenever we start doing a project, we start with a blank sheet of paper, and there's millions of options. And I have personally told my stakeholders, product owners, or whoever, if you give me time and if you give me money, I can build you anything, whatever you want. If you want a dancing unicorn when you press the order button, fine, we'll code it, right? We can do that. And then we start building solutions. And again, it's a clean slate. And in our world, we build a lot of choices. And if we have a lot of choices, frameworks, languages, components, features that you do or do not want to build, each of these choices add complexity to the project or the product that you're building. And eventually we end up with diagrams looking like this on a whiteboard, and we get confused and we think, man, is this rocket science what we're building here? And I've seen this happen with fairly simple, which should have been fairly simple projects, and still we mess up. And I think that's something that we do as an industry. We make it ourselves a bit complicated every now and then. And since I'm passionate about space and the rocket industry, I did some investigation to find out what can we learn from these other businesses. So if we take a look at these kind of projects, what are the similarities? What are the differences? And there's not much need to dive into the details here. Obviously, the difference is that these things tend to explode and cost a lot of money. And for most of the software projects that I'm on, things don't really explode at the end. But it's good to note that in the end, these things don't fly without software. There's software in these rockets as well. And if the software doesn't work, this happens. Is anyone familiar with this video?
Tous les paramètres propulsifs sont normaux et la trajectoire est normale.
Okay. Yeah. So this was Ariane 5, the maiden flight, European rocket. We don't have currently an operational European rocket, but there will be one. The problem causing this were these numbers. Do these look familiar? The bottom one might seem familiar for developers, because that's a 16-bit integer. The top one is a 40-60-bit float. And what happened is that somewhere in the software, the top one got mapped into the other one and overflowed. And then the guidance system made an error and the rocket self-destructed. That was a costly software mistake. So at one side of this talk, we can do these kinds of things and make things explode. And the other side, we can do really awesome things and deploy Curiosity onto Mars. Not sure if people have seen this clip before, but this mind-boggling. This thing traveled 563 million kilometers onto the surface of Mars, made an entry through the atmosphere, had this kind of flying drone thing, which lowers the actual rover onto the surface, and that's still driving around there today, taking soil samples, making pictures, even selfies, and doing awesome stuff on the red planet very far away from here. Again, a lot of software in here, which is very difficult to test if you don't have the exact environment on Earth, as you can probably imagine. Written in assembly, is that true? Oh, wow, okay. Yeah, we had a talk on green software, and someone asked what's the most efficient language to write in from a greenness perspective with the least amount of carbon. And assembly, because you're so onto the processor, you can make it very efficient. So that's probably the reason why they use it as well. Yeah. So why is this all important? If we look at building software and we regard it as a manufacturing process, then you have input on one side, like requirements, like people and skills and some constraints. We've got people and processes in between to take the input and to transform that into output. And in essence, this isn't really that different from building a product or building a rocket. It's also a manufacturing process. You're just manufacturing a different thing. But in essence, it's not that different. So if we peek into other manufacturing industries, we might learn a thing or two. And we already did as an IT industry, because if you look at Kanban, for instance, and also Lean, those came from Toyota, which is a car company and not a software company. Although now in EV market, opinions differ. But so if we start looking at space industry, then of course we want to take a look at the company which performs best. This was the up mass in kilograms of spacecraft from Q3 2023. It's probably not a big surprise for people who follow the space industry a little bit that SpaceX is on top. Does anyone want to guess how many kilograms they put into space, roughly? Yeah, way more. Yeah. So these guys outperform everyone. Imagine that, I know that velocity is not a thing to compare between teams, but just for the sake of the argument, I will. Imagine that you have a couple of teams and your team is doing this versus the other teams. That would be great, right? So why are they so much better than the rest? I wanted to zoom in, and I want to touch, if we talk about SpaceX, we have to talk about Elon Musk, and he did this let's sink it in joke when he bought Twitter. I know that some people really dislike Elon Musk, but I want to emphasize that SpaceX, of course, is led by him, but it's still a bunch of people. Very brilliant people, probably, but still it's people doing this. So if we look at their way of working, then you can find out this is public information. There's not a lot of public information because these things are all governed by the US government with rules and regulations. But there is some stuff you can find, and one thing you can find is their 5-step process. And I think that's something that we can learn as an IT industry from how others do it. And the 5-step process consists of 5 steps, obviously, of which the first one is question the requirements. Starting by, your requirements are probably dumb, and you should work to make them less dumb. I don't know if people were in Kenny's talk about DDD. Having the domain conversation with your stakeholders to really understand what is going on here is still very important. And we see a lot of customers where user stories are only a title or few lines with which you'll have to either make a lot of assumptions or have a lot of background knowledge yourself to understand what is really the thing that we're trying to do here. So question the requirements, question everyone, and especially the smart people. We tend to assume that if the person that you're talking with is very smart, you tend to assume they'll probably know, right? They'll probably know what's best, and you don't tend to question them as much. Do. No matter who you are, this is the other side. If you're maybe the smart person, no matter who you are, you're going to be wrong at some point in time. So own those mistakes and make sure that you go back on them. I worked at a customer recently where some of the architects made a decision at some point in time and a year later had to come back to that decision. And that takes courage, right? It takes courage to say, right, sorry, it was the wrong decision. Because that took a lot of money, a lot of time, and now needs to be fixed. And if you're going to question the requirements, make sure that you drill down on the requirements and you break the high-level requirements down. For instance, if we take a look at the space industry, then you might say their basic requirements are very simple. Because they've got a payload, and the payload has a dimension, a weight, and it needs to go into a specific orbit, right? Simple enough. But if you dive into the details, everyone will understand that the task of getting the thing there is not as easy. And if you question your requirements, you might find out that the payload looks like this, which makes it a bit more complicated to get it up there in the right way. So that was, one more slide. And if we then look at the requirements from a software perspective, most of you might have seen this before. This is what we tend to do. And we sometimes build the wrong thing or build it in the wrong way. So questioning the requirements is a good thing to do. Then for the second step, they say delete the part or the process step. Try to remove things again. And if you're not occasionally adding things back in that you previously removed, you're not trying hard enough. That's their mantra. So you need to make sure that you strip away things that you might not need anymore, or at least question, do I still need this? And we as software engineers, I've seen this happen over and over again, we tend to add things, but not really remove them. So it gets bigger and bigger and bigger, gets more complex, gets hard to maintain, etc., etc. Everyone knows these kinds of issues. The pitfall of saying let's add in just in case, and this is something that we need to educate our businesses and stakeholders as well, ensures that you're adding complexity. It's more, you make it bigger, it's more choices, makes it harder to maintain. So we start off with this, we migrate into that, and we end up with the big ball of mud, which is not maintainable. And at some point, of course, there's going to be some migration onto a new system or a new version of the platform or whatever, and then we're in trouble. So keep on removing stuff. Then for the third step, simplify or optimize. They state the design is always wrong. The question is how wrong and where are the errors? There's 1,000 ways to solve a problem, and that doesn't make solution A any better than solution B. I've seen teams have endless discussions about who was right, where both solutions were perfectly viable. But the key is to find out where are we making mistakes, how can we fix those mistakes, and how can we ensure that a future design doesn't get these mistakes in the first place. And that again boils down to thinking about this up front instead of jumping into solution building. And if we add complexity, then use simplification or optimization to reduce it and try to reduce it. If you're aware of complexity that you're adding, and that could be a choice, right? At some point in time, you might say, okay, we're going to introduce a bit of complexity here just because we need to right now, we need to get this done. Then make sure that you're going to reduce that afterwards. For that, you need to revisit and rethink the design. And the process here is first delete it. Then, if deleting is not an option, simplify. And if simplifying is not an option, optimize. A quote here, one of the most common mistakes of smart engineers is optimizing something which should not exist. Anyone been there? I have. We do this, right? We optimize stuff which later on doesn't turn out to be necessary. The background image here, I promised the gentleman in front that Raptor will be part of the presentation. The background image is a shot of the engine bay of Super Heavy, the rocket that SpaceX is building right now. This consists of 33 of these engines. And if we take a look at how they implement these practices, this is their first version, which they don't use anymore. It worked, right? This was a perfectly functioning rocket engine which already outperformed a lot of engines out there. So they could have said, we're going to stop here, this is fine, wrap a bow around it, and that's it. But they didn't, so they made a version 2, which, if you take a look at the numbers, performs even better. And I don't think you need to be a rocket scientist to understand that the second version is more simple than the first one. Less wires, less parts, it looks cleaner, right? And then they didn't stop there either. There's now a version 3, which is even more optimized. And a lot of stuff, at some point, we're going to wonder, is this really all that it needs? Because the left one is very complex, and now it seems to be very simple. Does it do the same? Yes, it does. And it's even more efficient than the previous versions. And we can all understand that the thing on the right is easier to build, it's easier to maintain, there's less stuff to break. So if you can improve it, then please do. Yes? Good question. When the fourth one will be out, I have no idea. But they're probably working on it. I would be surprised if they're not, yeah. So this is really in their DNA to continuously think about how can we improve things, how can we make it better. And of course, they need to work to some deadline, and there's money to be made in the end, and that's also important. But they take the time to revisit all of their thoughts, all of the decisions that they made earlier, to reflect and see, does this still apply? Is this still a valid thing to do right now? Do we still need it, or can we maybe get rid of it? All right, so step 3. Then step 4 is to accelerate the cycle time. Go faster. Eliminate the technical and process bottlenecks which you might have. Reduce time to get a feature into production, of course, with CI/CD and all the wonderful stuff that we have today. We can make sure that we speed up our own cycle time to get our software into production, where we get the feedback from our customers to understand what is our product doing and how can we make it better. And this also removes distractions if you do it right. And some of you might have seen that graph before. This is for a specific person. So if you're taken out of your zone, right, you're coding, something distracts you. It might be email notification popping up, or some notification on your phone, or someone coming by at your desk. That breaks your flow and it hurts your concentration. But that also applies to teams and to departments in general, right? If a product owner isn't stable, or the flow of features isn't, and you're continuously have to contact swap between this person wanting this, that person wanting that, that tends to hinder your ability to accelerate. So from my point of view, where the step 1 with the requirements is something in which product owners are heavily involved, this should be something that Scrum Masters should worry about. How to get your team to be really effective and to get every bit of performance out of them. If we take a look at these logos on the slide, all of these companies have one thing in common, and a lot of other companies do this as well. They advertise with the fact that they deploy their software into production multiple times a day. And I have this conversation with our customers as well, and we tell them, do this, start doing this. Start deploying your software into production multiple times a day. And they look at me and they say, why? We're not Facebook, doesn't matter. We deploy every 2 weeks or maybe every month, and that's fine for us. We don't need to go any faster. But once you do follow that practice, you'll find out where your bottlenecks are. If your deployment process has a single manual step which someone needs to do, it's probably fine if you deploy once a month. Could be fine if you deploy once a sprint. But once you start targeting deployments every day, that becomes an issue. And you can't really do that anymore, because you get very dependent on that one person doing that one task. And it could also be maybe a sign off from some architect or a change advisory board or whatever. All of these things you will find once you start trying to deploy as often as possible. So try to do that, and by that accelerate your cycle time and make sure that all of the things that are in place are as fast as they can be. Then the last step of the 5-step process is to automate. I repeat, this is the last step and not the first one. And a lot of people, we're solution builders, right? We build solutions for our businesses, for our customers, and we tend to think in solutions. At least I do. As when a customer comes by and they have some wild idea, my brain goes on and thinks, oh, we need to build this and that, and we skip things. We skip the first few parts and we go straight on to automating things and building things, and not really care about the steps before. If we're going to automate, do it with a reason, and those reasons should be things like repeatability, scalability, reliability. This can be longer, but those should be the reasons to automate, and not just because we can. And if we follow these 5 steps in this order, so the order is important here, then you don't automate before you've done all the other things, because you'll be automating the wrong things, maybe, or things that haven't been optimized yet. Yeah, question. So the question is, how can you go live with an application multiple times a day if you don't automate? Yeah. 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 So this is a thing that you don't, this is not a one-time thing, right? This is something that you need to include into your iterative process and keep repeating. So it's not like you're going to take 3 months' time to simplify and optimize. No, with every iteration that you do, and for that our way of working with Scrum and Agile is very good fit. Build in these steps and make sure that for little bits of functionality you do these steps. So you've done the automation already in previous steps for that part, but you shouldn't automate the things that in a next cycle you might delete again, because that's a little bit wasteful. Yeah. Okay. And this I've done myself as well many times. All right, so this was a little peek into the manufacturing process of SpaceX themselves. So this process you can find, they've written a few blog posts about this as well. Unfortunately, apart from that, there's not really that much information that you can find, and SpaceX is one of the companies which tends to be very open in the limit that they have from the government. If you take a look at more traditional companies, there's almost nothing that you can find. Luckily, there are similar companies which follow the same design principles and which are also founded by the same guy. There's Tesla, for instance. And we can take a look at them because they have a lot of principles as well. And I wanted to pick out one specific one, which we'll find if we look at their factories. So Tesla built the Gigafactory, the latest one they built in Berlin. And the next one is going to be somewhere South Africa, I believe, or India. Not entirely sure. At some point in time, they said, our factory that we're building is part of our product line. The factory is the product. And that means that they're applying the same principles to their factories as well. And you can see that if you take a look at the blueprint of each factory, which they tend to have in their presentations. This is the blueprint of a somewhat more traditional car company. So they'll have satellite photo, right? So taken from up high. They'll have several buildings for each function or each part of the manufacturing process. So there's paint and body and stamping, et cetera, and there's these lines of parts moving in between those buildings to eventually get to a complete car. In the iterations that they made within their factories, for each new one that they built, they didn't copy the one that they have, but they looked at their manufacturing process and thought of how can we optimize it and how can we make sure that we're doing things in the most cost efficient, probably also, way possible. This is the layout of one of the last factories that they built. And as you can see, they're placing things as close together as they can, and they think about what is the sequence of events that eventually leads to a car coming out of the factory. And in my opinion, looking at your manufacturing process in this way is something that we should do much more often. And that's because something which is known as Conway's Law. Is that familiar with people? Conway's Law states that the design of a system tends to follow the way that the organization that built the system is organized. at least the communication flows within the organization. And the most simple example which I tend to use is, imagine two companies. One company has a centralized team of database experts which maintain and make sure that all the databases are up and running, etc., etc. And the second company has cross-functional teams with database expertise in every team. Imagine how the database situation within these two companies will look like, what it will look like. And you probably can imagine that in the first example, you get a centralized database server, one technique, because that's the thing that the team knows, right? It's SQL Server or it's Postgres or whatever. Doesn't matter, but it's one big database server within the company where all of these teams need to put their databases. In the second organization, chances are that each team will have their own database catered for their needs. And that's an example of Conway's Law in action, where you see that the way that the organization is built and the way that the organization is structured can be found in the actual products that they produce, the software that they build, and the solution designs that they make. The funny thing is that the inverse is true as well. So you can turn this around and you can say, if we know what we're trying to build, if we know the layout of our factory and what would be the optimal way of producing our software, we can start adapting our organization to fit that same layout. But that's almost never done. I see a lot of companies where IT departments tend to be the same years over years, and the only thing that changes is that people are put in different roles which they're not accustomed to, and in some cases also don't fill in that well. That's a different problem. So if we take a look at, again, the way that Tesla builds up their factories, they're thinking about this. They're thinking with each iteration of building a new factory, how can we make it more efficient than the previous one? And how can we make sure that the way that the factory is built is lined up with the stuff that we're trying to produce? And that's what they mean with the factory is also part of the product. We're improving on that factory as well. Skip through this one. So again, going back to the beginning of the presentation, if we take a look at software development from a manufacturing point of view, and I know I don't want to, especially not in the light of the AI discussion, I don't want to get across the message that we're all like conveyor belt workers, right? Screwing on bottle caps or something. This is highly complex work, but it is still manufacturing, and there's stuff that we can learn from other industries. So think about this. If you find this interesting, we've got a white paper listed on our website, which dives a little bit deeper into the topic of software factories. And then for a quick recap, as an IT industry, I think we can learn a lot from looking at other industries. So if you and I like space, maybe you do as well, but maybe you have other hobbies like cars or working in the garden or I don't know. But if you open up your mind and take a little bit of time to look at what other industries have already done. Another good example is construction, by the way. The construction industry is, there's a lot of standards and things catered in there, and you might, that might feel a bit confining from where we come from. But I know for sure that if you make an architect do a drawing and you go to a contractor with that drawing, he will understand it. If I take a drawing from a random IT architect and I go to a company and I ask them, can you build this? I'm pretty sure that they will say, well, we might need a little bit more explanation. So we should, as an IT industry, look at different industries. We should find out why other companies are faster than us. We should find out why they're more efficient in building products, and it doesn't matter if that's software, it could be other things as well. So take that with you and think about your own team, your own department, your own company, and what you can improve. The 5-step process from SpaceX is something that you can apply, and if you want to take it one step further, because that's something that's really applicable within a team. If you want to take it one step further and you want to look at your whole department or maybe your whole company, then start to think about what are the things that we try to build and how should we adapt our company to fit the thing that we need to produce. With that, I'd like to end, and it's time for drinks. If you're interested in these rockets, I highly recommend. They're about to launch the 4th test flight of their super heavy Starship combination, SpaceX that is. I don't think there's a planned date yet, but it's on the pad and it should be somewhere in the coming weeks. These launches are very spectacular to look at. So I highly recommend checking that out. They're all on YouTube, so you can find them there. With that, I'd like to thank you for your attention. Enjoy the drinks and the rest of the conference. And a good way out.